Hey, hello everyone, welcome in a new video. Xavki here. I'm thrilled to find you for this new video, and we will continue our learning pipe to discover Kubernetes. And today we will discover what is a stateful set. So let's take a look. For a stateful set, just a global or high-level things. Previously, in previous videos, we discovered the deployment to manage our pods, but this is not the only way that you can use to create some pods and to manage it inside Kubernetes. You have the deployment, but you have the stateful set and the daemon set as well. So stateful set and daemon set can manage and create pods directly, like the deployment. A part of the manifest of stateful set or daemon set is like the deployment manifest, in fact. And we will see the daemon set in the next video. We will see what and when we want or you will want to use it. But in fact, for stateful set, maybe you have it in mind. This is for stateful applications. Stateful applications, it's like database, or when you want to store data and to store static and stuff like that. It's really interesting to use a stateful set because you have some features inside stateful set that that help you to manage easily the volumes. So the first thing is that in the manifest, in the stateful set manifest, you have the persistent volume claim template. Like you have inside the deployment the pod template, you will have inside the stateful set the pod template, but the persistent volume claim template as well. The second thing is the name of each pod. With the deployment, remember you have some random IDs into it, like the name, and after that the ID of the replica set, and then the ID of the pod itself. But with the stateful set, we will use the name of the pod, or the name of the stateful set, in fact, dash an incremental number directly, so dash 0, dash 1, dash 2, and so on. And it's really useful to manage each stateful set like a part of this to manage pods inside the stateful set, like a part of this stateful set, but a static part, in fact. So it's really interesting, and that will ensure to associate a pod with, for example, dash O like ID, or dash 1, whatever, to associate it with a specific persistent volume. So it's really useful for stateful application. Aside of it, what do we have? We have a DNS, but not only for the service, like for deployment, but there is a specific DNS with stateful set for each pod. Meaning that if you have MySQL -0, MySQL -1, and so on, you can directly use the DNS, the entry DNS for each pod if you want. So this is what we use through the headless service. So it's a specific service. We already saw the cluster IP service, the node port service or load balancer service, and now you have the headless service. The headless service, in fact, is just a cluster IP service set to none. And the IDs of each pod, so dash 0, dash 1, dash 2, and so on, is really useful because when you will use a rollout for rollout replace or rollout restart and so on, you can be sure that all will be in a specific order, and it's an incremental order, meaning that you start with dash 0, then after that, when the pod dash 0 will be up and running, you will restart, for example, dash 1, -2 and so on, like that. So it's really useful to manage this kind of situation, and usually it's the case for stateful application. So like I said, you just need to add inside the stateful set, so the service name, and that you need to create a service name, a service headless, so it's cluster IP set to none, and to associate it with so inside in fact the deployment manifest. You will need to define a template for your PVC, but it's really interesting, in fact, because that avoids to create some other manifest to create some PVCs, and that and we will see that that allows you to use directly the storage class inside the stateful set manifest. So it's really useful and really easy to use, for example, the dynamic provisioning. We will see that in the second part of this video for the demo. Then we will have the name, and even if you restart, scale down, scale up, the name will be kept, and it's really interesting for stateful application. So the volume claim template is just this kind of block that we will add inside like the deployment of deployment manifest, but it's a stateful set manifest, and into it you will have the volume claim. So the name of the volume claim, it's like a volume. That means that if you want to use this volume claim template, you need to add a volume mount inside the container where you want to mount it. You can associate a storage class name like here, and it's that's it. In fact, with a persistent volume and just the storage class. And if you use just a dynamic provisioner with just a storage class, you just need to have only one manifest, so the stateful set manifest, and set here the storage class name. And you can set the access mode and the storage class volume. Another change inside the stateful set manifest, you need to set the service name, like here, and the service, it's just a classical cluster IP service, but just we set the cluster IP to none, and that's it. The internal DNS, it's a classical things on the left, so you have the stateful set domain, classical thing, the service domain, but on the right you have the pod DNS, so it's new for us, so it's an entry, DNS entry specific for each pod. You can see here web-0, web-1, and so on. So you need to set the pod, then the service name, then the namespace, then SVC, then cluster local, or the name of your cluster inside your settings inside the cluster. Of course, you have some shortcut directly inside the pod. You can use, if you are directly inside the namespace, you can use the usual tricks to not set the entire entry and this long entry. The demo, we will do two demos inside this video. The first one will be based on host path. Host path and Statefulset is really useful to manage, not with Nginx. Nginx it's just for the demo. It's just to manage it easily and to show you easily how to use it. But in fact, it's more like MySQL or Postgres and Cassandra and so on. But when to use, for example, here the host path, you want to create, you have like an instance, so a server in the cloud or on-prem, and you want to use your SSD, your local SSD to ensure the performance, meaning that low latency and IO, throughput. And to do that, you need to use a host path. And for that, you will create a persistent volume with the name, for example, of the node, and you will create at each node you will create this a persistent volume dedicated to it. Okay, so it's not really easy to use it, but it's a really good way to ensure the performance inside Kubernetes. So you will create it maybe and for sure manually. No, not manually, automatically. So it's a joke. And you will define the path that you want to use locally, where you mount, for example, your file system on it. Okay, but you want, for example, to schedule exactly the same pod for each mount. And to do that, you want to ensure that you have -1 on the -1 server or the name that you want to attribute to it. But when these things is done on all servers, that fit really well with high performance and database, in fact, when you want to keep your storage associated to the pod. And if you restart, for example, the -2, you will have the -2 on the server if you delete it and recreate and so on. The second demo will be with the dynamic provisioning. Really interesting part, because we will use our NFS provisioner in our case, but that can be another storage kind of storage. It's NFS, but that can be Ceph, CephFS, and stuff like that. And automatically, our provisioner will create each NFS directory with the storage class associated inside the Statefulset directly. So it's quite magic, but it's really, really useful and easy to manage. You will see that, and our storage will be, and that will be an external storage. For the demo, it's quite, and it's really, really simple things, and you, for sure, you need to improve it if you want to go in production with this kind of things. But it's just a demo to give you an example and to keep it in mind. In the next video, we will see daemon set. So let's go for the demo. Let's get started. And we have here 4 nodes inside our server. My master is the 10, and our worker is from 11 to 14. And I can create a directory, a dedicated directory. I can go into this directory. The first demo is on host path, so that means that we need to create our Statefulset. We need to create each PV on each server, meaning that we will do exactly the same thing with 3 nodes. So 3 persistent volume. We need to create a storage class to associate the persistent volume claim and the Statefulset, in fact, with the persistent volume claim set inside the template of the persistent volume claim. So we will need to use the storage class and the Statefulset and the service, so the headless service. Okay, so let's go. So feel free to use the video description links. You will find the link to my GitLab, and you can clone this repository, and you will find exactly what I have for this video. So the first thing that we need to do, like I said, is to create first the storage class, like here. So it's a manual, so I set it as a manual storage class. So if I check storage class, we have the storage class manual, perfect. And after that, I will create 1 persistent volume per node, meaning that I have 4 nodes. I will just create this persistent volume for each third node, so the 11, the 12, and the 13. So let me create the first file. So for PV1, it's key 0 11 here. So it's 11 here. So this is the name here of our persistent volume. We want to mount /mnt data. So this is a local directory, and it will be created especially with this persistent volume. Okay, and if you want, feel free to check and to have a look on the previous video to check how to create a node affinity for persistent volume, not for a pod, but for persistent volume. Okay, so I can apply this first manifest, and if I check the persistent volume, this one is available, and for the 11 node. So I can copy this file to create the 2 like here and the 3 like here, and I can edit PV2 with here the 12 and with PV3 for the 13. Okay, 13. Okay, so kubectl apply -f dot to apply all files. Perfect. So now I have all PVC here. All PV, sorry, PV. Yeah, I used Statefulset after that. So PV. Okay, and now the other thing that we need to set before the Statefulset is the service. So it's a regular service, but just into it, the cluster IP is set to none. That's why we will have a headless service, in fact. Okay, so this service can be accessed from an external access and stuff like that. It's only inside the cluster, only for Statefulset. Okay, so if I check kubectl get svc, have an nginx, perfect. Now what can we do? We can use our Statefulset. So it's a Statefulset kind, because we want to have a Statefulset, the name of the Statefulset, the service name. So this is our headless service. So set to nginx, we want to have 3 replicas, and after that a classical match label with the selector and template based on labels, and after that just a little tricks. 2 containers. The first one is just to set inside the index.html, because we will use in the second container nginx, and I want to provide the node name, the pod name, sorry, inside the index.html. Just a little tricks, and I keep slipped infinity just to use a sidecar and not an init container, because we will see in some further videos what is an init container, but right now we don't know, so I prefer to show you a multi-container pod. So into it, what do we want to do? We want to store this data and this file inside our specific volume mount on so this is the name of the volume mount, so nginx.-html. Here, just a tricks to set the pod name directly from a field path, so metadata.name. So it's a little trick, but it's a classical thing inside Kubernetes, in fact. And the volume mount is based on a volume, nginx.-html, and of course, it's our volume claim template. Volume claim template, we have the name, so this is the same name. The match is done on the meta name here, metadata name here, and this is exactly the same like here. So if you put here TT, you need to have TT here as well. After that, some specifications that you want to have for this persistent volume, and one of the most important is the storage class that we want to use to associate our persistent volume with this persistent volume claim and persistent volume claim template, the access mode and the resource. So it's exactly the same thing like previous and classical mount. After that, the second container inside our pod, so this is an nginx container, and into it we have a volume mount as well, just to provide the content of our index.html file. So it's exactly the same thing, the same name of course for the volume mount name, and it's not really useful to have the pod name here, because it's only used to define the index.html. I think you can remove these lines, but yeah, we can keep it in our case. So I copy and I will paste these lines. Okay, so let's go. And now if I check, I have a stateful set, perfect, with 3 elements into it, so 3 pods into it, 7 seconds. And if I check with the number of replica set, remember the alias is rs, no, sorry, yes, no replica set, because we don't use the deployment, of course. And the pod, we have some pods here, and like you see, we have started by the Nginx -0s and the -1s and the -2. So it's a specific order, because you can see here 32 seconds, and after that 15 seconds after that the second pod, and just after that and 15 seconds again after that the other pod. Now all is up and running. If we have a look on this part with -o wide, we can see that all pods are distributed across our cluster, because the 0 is associated to the 13 server, the 1 to the 12, and 11 here for the second one. Okay, so if I want to check now, I can check if I have some PVC. It's okay, I have some PVC as well. And okay, and all associated, so the -o is associated to the 13, because this is a mapping. So if this pod is on the 13, that means that we need to use the PV dedicated to the 13, and this is why we have this association here. And it's exactly the same thing for each one. Perfect. If I check the PV, we have a PV for each one as well. That means if I just, if I open another terminal here, and if I go on the key 0 C12, just a random number, and if I just check /srv /mnt data, have an index.html, all this part is created automatically. And if I check the content of this part, normally we are on the 12, meaning that for the 12 we use this one, so it's for the -1, okay, and it's -1, perfect. If I go, and you can be sure on all other servers we will have it. But imagine I haven't created a PV for the node 14. Imagine I want to scale, so kubectl stateful scale sts for stateful set, and the name of my stateful set, so nginx -- replicas, and I want to scale to, I don't know, maybe 5. Okay, let me check, let me have a look. For our pod, what do we have? We have another pod, so the next one, in fact, in our iteration, we have the -3, but it's on pending. And why it's on pending? Because there is no PV associated to the 14 server, so I can't spawn this pod, even if this pod is normally dedicated to another node. But I can't attribute this node, and the scheduler inside Kubernetes can't set the node name for this pod, because there is no, if the scheduler applied is a filtering mode, so the first part, the filtering after before the scoring, it just can't find a pod with all requirements. If I check here, normally I will have more details on why. So it's just right here. So we can see no nodes are available. Okay, didn't find available persistent volume to bind. Okay, because I need to set a new persistent volume. I can do it, of course, and we can do it. Yes, I can do it because if I copy, for example, the 3 and I set here set it to 4 like that, I can edit the 4 like here. And say, okay, I want the 14. So, okay, and kubectl apply dash kubectl apply dash f dot, like here, created a new PV. Okay, so it's here. And normally now, it's not automatic. Okay, in my mind, kubectl get PVC. Get kubectl get PVC, and I need, in fact, I could just cheat a little bit with the replica. Where is the replica? Yes, I can set it to 3 to keep it, and this is where it's interesting. Again, if I scale up and scale down, I will keep the order. Meaning that if I have the 4, the 5, and if I scale down, I never lose and I never remove the dash 0, dash 1, dash 2. If I want to scale down to 3, I will keep the dash 0, dash 1, dash 2, and 4 and 5 will be removed. Okay, and if I scale up again to replicas to 4, kubectl get pod. Okay, so container is creating, meaning that we are not in pending status, and at the end we will have the pod up and running. If I scale again, of course, I will see exactly the same issue. We will have the pending again and again. Okay, so this is the first demo. Now let me just clean a little bit what do we have. So kubectl delete Statefulset, and what do we remove? So the Statefulset is Nginx, okay, like here. So I can have a look. Okay, so it's terminating status. Let me just wait few seconds, because to remove the PVC and the PV, I will need to be sure that I haven't any pod mount with this PVC. So it's quite good. Normally that take 30 seconds if we don't manage the SIG term, so it's okay. So now I have PV and PVC, like here. I can remove all in one time. I can set dash all and use delete, like here, and it's okay. So now all is clean. Perfect. Now next step. So I can create another directory called here, so the demo1, for example, and in demo1, okay, I can now make another example. What we can do and what we need to do, first we need to connect on our key0ext, like here, and we will install just quickly the NFS server on it. So let me quick use our notes file to install it. So the first part is to install an NFS server here. So it will be quick. So we want to do that. In fact, create first the NFS server, then install the NFS provisioner. That will take a few minutes. And after that, we will use it with the Statefulset without to create each persistent volume, because they will be created directly from the NFS provisioner for a storage on key0x, so our NFS server. Then after that, what do we need to do? Yes, for each node, we need to ensure that we have an NFS client on it. So I need to install NFS command for Debian, for example, but for Red Hat, it can be another package. So key0 C11. Here I can run C13. Yes, and here the 14. Sorry, the 14 here. Okay. Perfect. And it will be okay. Perfect. And now let's go. I can remove this one and keep only this one. Okay. And what do we need to do? We need to install the NFS provisioner, like here. So let's go. And inside NFS provisioner, I need inside our cluster, we need to create the also a dedicated namespace to store our NFS provisioner. After that, I need to set the namespace inside the airbag and the deployment manifest. So to do that, I can run it like here, and then I need to edit into it the deployment. Deployment, and into the deployment I need to set here the path. So if I just run export fs sudo srv data, like here, so it's the NFS path in fact, so I need to set it twice. Okay, and after that the IP, so I can set the IP, my internal IP. So the same thing here. Perfect. You can script all if you want, but it's okay. And now we can reduce this. Okay, and now we can go directly inside deploy kubectl apply -f dot. I think it's enough to apply all airbag class deployment. Okay, and if I check after that, customization set with validate false. So I think it's quite good. Yes, I think it's good because we don't use customization. Perfect. And now kubectl get pod -n nfs system. It's okay. And we have now another storage class. So previously we created the manual. Now we have NFS client. Perfect. So nothing. If I just check in /srv data, just one default test, just a classical thing. It's an internal test, in fact. After that, we already created the service, the headless service. So no need to change it. And after that, we will use exactly the same Statefulset, but with NFS client as a storage class name. So this is the only thing. No PV, no PVC, and we just want to use the storage class. So now if I check kubectl get STS, it's okay. And if I check again kubectl get pod, it's up and running for the pod here. Perfect. For the second as well. If I check here in our SRV data, so we have 3 new directory, 1 per pod, in fact, so -0, -1, -2, and so on. If I check again for example, the -0, like here, where I am, yes, /srv/data, like here, /index.html, we can find the pod name that we have set with the busy box inside the Nginx pod. Perfect. What we can do, we can scale. Oh, okay. So you know that when we scale previously, we encountered some issue, and to test it, we can say, okay, I want to have 15 Nginx pod inside my Statefulset. So if I check, and that will be really interesting. So we will have, yes, the 4, the 3, the 4, the 6, and so on like that. And at the end we will have 15 pod, and you know, if I make kubectl get PVC or PV, I will have one PV for each pod created automatically. If I check the PV as well, exactly the same thing. And if I check my content, exactly the same thing. So now we are, yes, the 14. That means that we have 15 pod, and it's up and running. That's it. I can remove all the thing. So I can delete STS for Statefulset, the name of the STS, Nginx. I can remove it. So I can remove again kubectl delete PV and PVC, and I want to remove all, like that, and that's it for us. So just probably there is only one pod that we need to terminate, but it's ongoing, and that's it for today. Thank you for following this video, and see you in the next one. Bye bye.